Welcome to this HEC-HMS tutorial. Today, we'll walk through a beginner's guide using HEC-HMS version 4.12 and highlight some of the latest features along the way. Let's get started. Create a new project and call it HMS Demo. Now, let's define the basin model. This is where we'll set up the main structure of the watershed, including subbasins and river reaches. Next, let's add the terrain data, usually a DEM file. With HEC-HMS 4.12, we can automatically delineate subbasins right here in the software. This makes it much quicker to define watershed boundaries and get everything set for analysis. When adding terrain data, it's best to use coarse resolution files. These are usually in .tif format. Coarse terrain data helps speed up processing and is typically accurate enough for most watershed modeling tasks in HEC-HMS. After you import the terrain, make sure to associate it with your basin model. When you save, HEC-HMS will prompt you about using the terrain's projection. If you want to keep the same projection, simply click Skip to move on. To make your terrain look sharper in HEC-HMS, adjust the display settings. Go to Map Layers, select Terrain, then open Draw Properties. Under Display, turn Hill Shade off. This will give your terrain a cleaner, more defined appearance for easier viewing and analysis. Now you're set to delineate subbasins. Just go to the GIS tab and use the tools there to delineate your watershed automatically. The first option is the coordinate system. Since it's already set from the terrain data, you can just leave it as is, no changes needed. Next is terrain reconditioning in HEC-HMS, which lets you modify the DTM. The first option, build walls, is for raising elevations or creating barriers, but it's not often used in most projects. The second step in terrain reconditioning is burn streams, similar to hydrocorrection in HEC-RAS. Here, you import a shapefile of cut lines and set drop heights for each line. This helps guide water flow along the correct paths. However, the shapefile must be created in GIS first. Since my terrain is already hydrocorrected in HEC-RAS, I won't use the burn streams option for this project. Next, use preprocess sinks to fill small terrain depressions, then run preprocess drainage to define flow paths. Now, move on to identifying streams in the GIS tab. Here, you'll enter a threshold drainage area value. This tells HEC-HMS how much area is needed to define where a stream begins. Next, set your basin outlet using the breakpoint option in HEC-HMS. You can either import a GIS shapefile or draw the outlet manually. For this project, I'm drawing it manually. Just make sure your outlet point is placed right at the top of the identified streams. This ensures accurate watershed delineation and helps HEC-HMS define the correct drainage area for your model. When you create the breakpoint, name it Basin Outlet. This helps keep your project organized and makes it clear where the main watershed outlet is located in HEC-HMS. The next step is subbasin delineation. For convenience, I want to include junctions in my model, so I'll select Yes at the Insert Junction option. Then, after delineation, you'll see the new elements, like subbasins and junctions, appear in the Basin Model window. You can export the GIS layers created during delineation for use in other GIS applications. Now, let's set up the basin characteristics in HEC-HMS under the Parameters tab. For this demo, we'll just use SCS curve number method to calculate the subbasin losses. HEC-HMS 4.12 lets you calculate curve number using the built-in calculator. First, go to Components and open Grid Data Manager. Here, you'll create a new grid and set the data source as GeoTIFF to define your curve number raster grid. Once the grid is set up, you're ready to use the latest built-in calculator in HEC-HMS to calculate curve numbers for your watershed analysis. To use the HMS calculator, select the field you want to calculate. Check the Stats tab for variables and the Functions tab for math functions. Combine these as needed for your watershed calculator, available in the latest in HEC-HMS versions. For initial abstraction, just leave the column blank. In HEC-HMS, a blank field means it will use the default HMS computations automatically. Let's move to the transform parameter. We are going to use the Clark unit hydrograph option for all subbasins in this project. This method is reliable and widely used for simulating rainfall runoff response across watersheds and requires time of concentration and storage coefficient as input parameters. The HEC-HMS Technical Reference Manual describes several methods for calculating Clark unit hydrograph parameters, like time of concentration and storage coefficient. You can use empirical equations, calibration, or default values, depending on your data and watershed characteristics. Choose the method that best fits your project needs. For this demonstration, I'm going to use an empirical equation to estimate the Clark unit hydrograph parameters. Since we have a reach carrying water from the subbasin, we need to use reach routing. For this demo, let's select Muskingum Kunj with a trapezoidal channel. This method is simple and effective for simulating flow in HEC-HMS. Enter channel details as needed for your model. For greater accuracy, you can select the 8-point channel shape and use HEC-RAS to create an 8-point cross-section. Alternatively, you may treat the routing parameters as calibration factors, adjusting them to best fit observed data in your HEC-HMS model. Keep in mind that you can find reach-related information, like reach length, slope, etc., in the Reach Characteristics tab under the GIS section. Index flow or velocity is used in reach routing to set a reference flow or wave speed. Choose a value near the average flow. Now, let's add precipitation gauges in HEC-HMS under the Components tab. Then, create a meteorological model and link it to your basin model. For this demonstration, let's use a 100-year, 3-hour storm event. You can input the rainfall data in HEC-HMS by either importing it from a DSS file or manually entering the rainfall values. Choose the method that works best for your project setup. Pay attention to your rainfall data type, incremental or cumulative, and check the units. For this demo, I'm using the unit hydrograph approach. The next step would be to create a meteorological model in HEC-HMS to link your rainfall gauges to the subbasins. Assign the appropriate gauges to each subbasin within the model. This setup ensures that rainfall data is correctly applied, allowing accurate simulation of rainfall runoff processes in your watershed. For ideal modeling, you'd include meteorological variables like temperature, wind speed, pressure, and evapotranspiration. However, to keep things simple for this demonstration, we'll focus only on precipitation. This approach streamlines the setup and is often sufficient for basic rainfall runoff modeling in HEC-HMS. Do not forget to associate your basins to the meteorological model. By doing so, you can assign specific rainfall gauges to each subbasin for your simulations, ensuring that the correct precipitation data is applied throughout your basin. Next, in the control specification, simply set your model's start and end date and time and choose a computation interval. These choices tell HEC-HMS when to run the simulation and how often to calculate results, making sure everything lines up with your storm event and analysis needs. For consistency, I always check start date and time used in the precipitation gauge time series and copy it over to control specification start date. You can set the model end date based on how long your storm lasts. This way, the simulation covers the entire rainfall event and captures all the important runoff in your watershed model. Make sure your time interval is small enough to capture key changes during your storm event. Lastly, before you run the model, create a simulation run in HEC-HMS. This is like making a plan in HEC-RAS. Here, you choose the basin model, control specification, and meteorological model that will be used for your watershed simulation. This step brings everything together for analysis. Once everything looks good, hit the Run button at the top and look for any error message that may appear at the bottom. If model runs without any errors, you should be able to see hydrograph and other tabular output under Results tab. Always check the hydrographs for realistic peaks and timing, review total runoff volumes, and compare results with observed data if available. It's worth noting that HEC-HMS allows for auto-calibration of your model. Remember, every HEC-HMS model should start with a clear goal in mind. The level of detail in your HEC-HMS model should match your project's needs. Always let your modeling objectives drive your choices. This way, you'll build models that are accurate, manageable, and truly useful for decision-making.